Assalamu alaikum warahmatullah. In today's lecture, we are going to discuss about the thermal analysis techniques. First of all, we will see that what are the thermal analysis techniques. Thermal analysis is a group of techniques that study the properties of material with respect to changes in temperature. For example, in all the thermal analysis techniques, we have a plot between temperature, and here we have the changes in properties, and y-axis we have the change in properties that in different thermal analysis techniques we have different properties here, and in x-axis we are actually changing the temperature, and here we are observing the change in the properties. There are a group of thermal analysis techniques. For instance, we have thermogravimetry analysis, TGA. Here we are looking into changes in mass with respect to temperature. In differential thermal analysis, we are observing the temperature difference, and we are observing the temperature difference and with respect to changes in temperature. In differential scanning calorimetry, DSC, we are looking the heat difference and with respect to temperature. This heat difference, you can say that enthalpy of the reactions and with respect to temperature. This whole slides indicate that the properties that exist with changes in temperature, there could be a number of properties, and in each case, in each individual properties, we have designed a particular device and giving it a different name. That is a particular thermal analysis technique. For example, if we are looking into changes in mass of the sample with respect to temperature, it means that we are actually studying the thermogravimetry analysis. And if we are seeing the temperature difference with respect to temperature increase or decrease, it means that we are studying or we are utilizing the DTA technique. So there are number of techniques exist in thermal analysis. First of all, we are going to discuss about the TGA technique, thermogravimetry analysis. This is the equipment that is utilized for TGA, and here we are going to discuss the journal information of thermal analysis apparatus. In thermal analysis apparatus, we have four major components. We have a furnace where we place our substance, and then we have temperature programming, where it is programming, data acquisition system, and we have a thermobalance. So the physical property that we measure with this whole setup is mass change with respect to temperature. So measuring changes in weight in relation to changes in temperature. This is the basic principle behind TGA machine. We are looking into the changes in weight of the sample as we change the temperature of the substance. The measure weight loss curve gives following information. We are gaining, we are observing, or we are extracting these three information from this graph. This is the a thermogram or graph between a temperature, and here in y-axis we have a change in mass. So we obtain different curves for this sample. As we increase the temperature, this mass could be increased or it could be decreased depending upon the reaction kinetics of the substance. So from this graph we can obtain these kinds of information. First of all, we can find out the changes in sample composition. If there is a change in composition, it means that there could be a reaction have been occurred, and that reaction is actually changing the mass of the substance. And secondly, we can also observe the thermal stability of the substance. If here we for instance is stable at that range of temperature, but as we increase the temperature further, it could be increase the mass of the substance. If that mass increases, it means that the substance is not stable anymore, and that is basically oxidized. And if that mass is decreases, it means that the decomposition of the sample have been occurred, and it is changes into some some other substance which involve the gaseous phase, and as some of the substance is changes into gas state, that's why the mass of the substance decreases. Now the kinetic parameter for chemical reaction could be also found through these techniques. A derivative weight loss dm can be used to tell the point at which weight loss is most apparent. Sometimes it is observed that do not obtain a very cleared, a very resolved peak for temperature at for example, we cannot identify that at what temperature the change have been occurred. So for that, to get the very clear idea and to resolve this problem, we actually take the derivative of the mass, and it also this derivative give us a very sharp and very resolved peaks, and so from these curves we can actually obtain the exact temperature that where this chemical change or physical change have been occurred. Moving on, here we have all the information. We have a flow chart from where we can observe that what kind of information that we can extract from the TGA curve. As I have already told you that thermal stability of the material could be easily studied by using TGA curve. If material is unstable at particular temperature, there could be changes in mass, and that would actually indicate that material is no more further stable at that temperature. We can also so this is the fingerprint. TGA curve is the fingerprint for a particular material at so that we can identify that at what temperature the material is stable or at what range of temperature the material is stable. Secondly, this point is also relevant to stability of the material. Oxidation of metal in air, oxidative decomposition of organic substances in air, or thermal decomposition is in inert atmosphere. These are the main indicator that at what temperature the material is oxidized or at what temperature the material is decomposed. These could be also identified using, these information can be also extracted using TGA curve. Further, moving on, the composition of multi-component system behavior sufficiently different on the temperature scale can be identified and reaction mechanism formulated. This point we will also look into this point in details in coming slide, where we will discuss a particular case where there are multi-stages decomposition of a material occurred, and at each and every stage there is a new component formation, multi-component system, and actually that system would be a multi-component, and when we heat from a low temperature to high temperature, there are multiple chemical changes, and these changes indicate that how many new component are formed during decomposition of the sample. So this example could be easily understood by using that curve, and we will discuss this point in coming lecture or coming slides in detail. Moving on, the lifetime of the product could be estimated using TGA curve. Decomposition of kinetic of material, rate of reactions, and activation energy could be also find out using TGA curves, and these are all the information could be extracted using TGA curve, and we will discuss each and every case for getting all of these information in coming lecture. The effect of reactive or corrosive environment atmosphere on the material, oxidation and corrosion studies, and lastly moistures or volatile content of material could be also identified using TGA curve. This is all the introduction of thermal analysis techniques and TGA. In coming lecture we will